Hello and welcome to this video on using decorators in Spring Components. In this video, we'll explore how to use decorators to create flexible and reusable code in Spring Framework-based enterprise-grade applications. First, let's define decorators. Decorators are classes that modify the behavior of other classes without changing their code. They're commonly used in Spring Components to add functionality to existing beans. This approach makes it easier to add new functionality without changing the original code. Decorators are commonly used in object-oriented programming and are particularly useful in Spring Components. Spring provides a powerful mechanism for implementing decorators using its AOP, Aspect-Oriented Programming, framework. In the context of Spring Components, decorators are classes that wrap around existing beans and provide additional functionality without changing the original code. For example, if we have a service that retrieves data from a database, we could use a caching decorator to reduce the number of database calls. The caching decorator would wrap around the original service and cache the results of the database calls. This way, subsequent calls to the service can return the cached data instead of making new database calls. The beauty of decorators is that they allow us to add functionality to existing beans without changing their code. This makes it easier to maintain the original code and to add new functionality as needed. In fact, decorators are so powerful that they're often used in large-scale enterprise-level applications to improve their scalability, performance, and maintainability. In enterprise-level applications, data access is a critical aspect of the system's performance. However, database calls can be slow and resource-intensive, especially when dealing with large amounts of data. Caching is a technique that can be used to improve performance by reducing the number of database calls. Let's say we have a customer service that retrieves customer data from a database. This service is called frequently from different parts of the system, and the data it retrieves is relatively stable, i.e., it doesn't change frequently. In this case, we can use a caching decorator to improve the service's performance. The caching decorator works by wrapping around the original customer service and caching the results of the database calls. The first time the service is called, the caching decorator retrieves the data from the database and stores it in a cache. Subsequent calls to the service can return the cached data instead of making new database calls. This can greatly improve the service's performance, especially if it's called frequently. Real-world examples of caching include caching the results of expensive computations, such as machine learning models or complex algorithms, to improve performance. Another example is caching the results of web service calls to reduce network latency and improve the user experience. Caching decorators are a powerful tool for improving the performance of enterprise-level applications. They work by caching the results of expensive operations, such as database calls, and returning the cached data instead of making new calls. Caching can greatly improve the performance of applications that are called frequently or deal with large amounts of data. Now, let's look at some code. Here we use Spring's auto-wired annotation to inject the original customer service and a cache manager instance. The getCustomerById method first tries to retrieve the customer from the cache. If it's not found, it calls the original services method and caches the result for future use. In this way, we keep the original implementation of the customer service class clean by following the single responsibility principle of object-oriented programming. That class worries about data retrieval and our caching customer service decorator class worries about caching. In enterprise-level applications, reliability is a critical aspect of the system's performance. Sometimes, network or service issues can cause operations to fail, resulting in a poor user experience or even data loss. Retry mechanisms can be used to improve the reliability of the system by automatically retrying failed operations a certain number of times before giving up. Let's say we have a mail service that sends emails to customers. This service is critical to the system's operation, and the emails it sends must be reliable. However, network or service issues can cause the email sending operation to fail. In this case, we can use a retry decorator to automatically retry the email sending operation a certain number of times before giving up. The retry decorator works by wrapping around the original mail service and retrying the email sending operation if it fails. The first time the service is called, the retry decorator delegates the email sending operation to the original mail service. If the operation fails, the retry decorator automatically retries it up to a certain number of times before giving up. Real-world examples of retry mechanisms include retrying failed database calls, retrying failed network operations, and retrying failed remote service calls. Retry decorators can be used in all of these scenarios to improve the reliability of the system. In this video, we learned the concept of decorators in Spring Components and provided enterprise-level Java code examples for caching and retrying functionality. Decorators are classes that modify the behavior of other classes without changing their code, and they are commonly used in Spring Components to add functionality to existing beans. The first example shows how a caching decorator can be used to reduce the number of database calls and improve performance in data access. The caching decorator works by wrapping around the original service and caching the results of the database calls, returning the cached data instead of making new calls. The second example showcases how a retry decorator can be used to automatically retry failed operations a certain number of times before giving up. This improves the reliability of the system, especially when dealing with network or service issues that can cause operations to fail. Both examples utilize Spring's AOP framework, which provides a powerful mechanism for implementing decorators. In summary, decorators are a powerful tool for modifying the behavior of objects without changing their implementation. They can greatly improve the scalability, performance, and maintainability of enterprise-level applications. We hope you enjoyed this video. Like our video and subscribe to our channel for continued videos on how to improve your coding skills.